So, just a quick video to run through a question that I've been asked many times is how do I turn a 2D profile into a 3D profile. So, if I connect to the sensor as I would do normally, and you can see here I've connected to the sensor. I've got my step target in under the sensor at the moment. For ease, I will put the profile display only on, and you can see our profile, our 2D slice of measurement here. Now we are providing X and Z, so along the width of the product and also the height of the product. So we need that third dimension, which is Y, and this can be provided by an encoder as the part passes through, or by a robot as it scans across a product. So we're providing X and Z measurements, and Y is provided by an external source. So once we provided those three pieces of data, we're then able to provide a 3D plot of such, or a 3D profile, by continuous scanning at increments to put those slices of this 2D profile together to give us that 3D. So as the sensor would be UDP streaming out or giving the data out via your Ethernet communication, I would simulate that by pausing and then saving the file to a CSV output. So if I click save here, that will then give me a CSV output of that profile. I can then go into the profile. So if we open the CSV file that we've just saved, you can see it comes out in this format here. It's not so much of a usable form, but you'll see it gives you the unit in time in milliseconds of when the profile was taken, the timestamp in seconds and milliseconds, and then obviously our X and Z data separated by a semicolon. Now Excel's not really the right sort of program to be able to plot 3D data, X, Y, and Z. It's generally for one or two XY plot type charts. To create a 3D plot, you can do it on Excel, but it's very complicated, and you need to create lots of formulas to be able to simulate the third axis. So to get this format of data into a usable manner, into a usable format, we have to select the data, and we have to go to data here, and we have to turn it from text to columns, and we are telling it that it's delimited by the semicolon. So we do that and finish, and now that gives us our X and Z information. So if I get rid of these, we don't need them at this time. But when you're adding your third axis, so the Y component, which will be either from your encoder or from a robot input, which is giving an encoder input to give you your slices of when X and Z are taken, and then you're stitching those together, you can do that. So just to show you what the data would look like on an Excel plot, if we go to insert chart here, you can see here that's essentially what our block looks like that we took the profile of. So that's just our one slice, X here, and our Z, which is the height information along the X-axis, is giving us those increments here. So I've not plotted that and not corrected the X-axis, but this is just what the Z height information looks like in a 2D plot. Okay, so what we now have to do is add our third component, and of course you can do this via UDP streaming, via Modbus TCP, whatever you want to use to take that third axis from for the Y information to give you your 3D data from the encoder input, you have to make sure that they're synced in time so that your X and Z is being taken at the same time that we're taking the information of in what Y value it is to give us that third dimension. So, okay, what I'll do now is clean up the data to get rid of these sides and also add our Y component of the different slices that I've taken. So I've taken multiple slices across the block itself at different points across 1 centimeter apart to then give you a simulation of what it would look like in 3D. So I'll clean that up and add the Y data. So I'll add our Y axis here in millimeters, and this is all been taken at the same spot, so it will all be what 0, and then I'll add the other slices in to then give us a whole lot of data that we can then import into a 3D plotting software. So now I've cleaned that data up and I've got X, Z and Y and different slices put together. So this was at 0 centimeters, then at 1 centimeter, then at 2 centimeters and 3 centimeters and 4 centimeters. We can now go ahead and take this data and put it into a 3D plotting software. And like I said, there are many available, both free and paid for. So I'll just copy this data and plot it into a 3D software. Okay, so I'm using this free 3D plotting software, but like I said, there's many available. All I do is with that copied data is load some data into there. So if I copy and paste the data into there and then press plot, you can see now I have my data plotted. So there you can see the different slices I've taken, at 0 centimeters, at 1 centimeter, at 3 centimeters, and at 4 centimeters, and those are the Z values. So the block at the top, the hole down the middle, and then the profile at the top again. So it doesn't look so great like that, but the software allows you to add different criteria into it. So now we're getting a bit of picture of what's going on. If I add meshes and membranes as well, now we're getting a bit more of an understanding of what's going on and what the profile looks like. So I had a very simple shape of that block, and these are the different slices stitched together to give us that 3D output, essentially. Z values being the height, X values being the width, and the Y values being the length of the product there. So just got to be careful of the units that you use, and also that they're all of the same unit value, so that you've got an accurate and scalable profile. So there we go. The software allows you to obviously twist and turn it and look at it in different ways. Now mine's a fairly flat and uniform product, but others have ridges and all sorts of other defects and things on it, so it'd probably look a bit better on the software itself, or a plot would look better, but just for simplicity I've taken a profile of a simple block there. I will, as per the picture I took at the start, will pass two other products through there, the angled block with a slant on it and a curve at the top, and also I'll do half of a cap, a small little cap that was part of a camera plug, and you can then see what a curved product looks like under the 3D plot. Okay, so as promised, I will now load in the other angled block with a curved and a slant on it, and I took this at 4 different slices again. So let's plot that data, And as I've kept the meshes and lines and membranes in place, you can see now what that looks like as a 3D plot. Same as before. If I look at it head on, Z axis is giving us the height, X axis is the width of the product, and the Y axis here is the length of the product. And it's all scaled to the values that and numbers that were given from the plot itself, and also from the Y slices that I've given it of 0 centimeters, 1 centimeter, 2 centimeters, 3 centimeters, and 4 centimeters to bring up this 3D type plot. So yeah, there we go. That's what it's looked like. And you can play around with zooming it in and out and rotating it and having a look at also the values as well, what the plot looks like, and visually have a look at what the plot looks like. So there we go. That's our angled block. Okay, so now finally I'm going to plot the cap. I only took half of the cap for plotting, and also it was every 0.2 of a mil, so it's half of that small cap that you can see. And because I haven't used the same units on the y-axis, it seems a bit more spread out. Now I can, in this software, put it closer together like so, and that's a bit more what the cap looked like as a profile. Now when I'm working with irregular plots like that, you'll see the meshes and lines don't work so well because the data points don't match exactly where the data points were taken on the previous scan. So wherever I was taking values in the x-axis, it wasn't taken at exactly the same points, so it doesn't mesh the lines together. But we've still got a representative of kind of what the plot looks like over a curved surface that was narrowing. So half of that little black cap that I had. Now on the last two slices, there were some points that matched on the x-axis to plot those lines together and make a line and a membrane. Other software does allow you to do a bit more rendering and things like that, but this is just a free bit of software. So you can see kind of what that cap looks like as it tails off. Okay, so yeah, just to summarize, the 2D OXM laser profile sensor gives us X and Z values. To add Y, you need an encoder or a robot input that simulates an encoder input, and we take slices at those specific points. We can then import that data into any 3D plotting software, free or paid for, and create a 3D plot and do some renderings and things like that with it. But we don't provide that or a software for it, but you can provide some easy visualization of what's going on with that 2D plot. Now if you choose streaming, is a lot of data to handle, so all of this X and Z value will be constantly pumping out from the sensor, and you need to timestamp that and synchronize it with the Y that you're providing from the encoder or the robot input to then be able to simulate the data and plot it all together in those specific slices. So hopefully that was useful, just to see that it can be done in an easy manner, and you can do fast via UDP streaming from the sensor, and also timestamping it and mirroring it up with the Y data that you're providing, putting all that data into a data source, and then you can plot it quite easily. Thank you.